Hi, good afternoon, everybody. Greetings from Dubai. Thanks for joining this webinar for DJI M300RTK and Phantom 4, and to show you how it can deliver a centimeter grade accuracy for AEC surveying, mapping, and 3D modeling. Today we have in the webinar people joining us from different parts of Middle East, from UAE, from other countries in GCC, as well as on the overseas and from African markets. Thank you once again for taking the time to register and to spend at least 30 to 40 minutes with us on this session. And on the chat box, there are two handouts for you, so you can download it while you see the webinar. There are like one data sheets, and we have the agenda placed on that. So the webinar title is basically to showcase how DJI drones, basically two models, DJI M300RTK and DJI Phantom4RTK, how it delivers, how it is able to deliver centimeter grade accuracy for surveying, mapping, and 3D modeling. We have going to take you through with the packages which can help with in terms of solution, including drone payloads, software, and also training. A bit of housekeeping before we go into the session. As a standard rule, we have muted the microphone for the attendees. The questions you can put your questions on the questions tab on your screen. The recording of the session is available and it will be made to you on demand basis once the session is finished. If there is any to be on the chat, there is a chat function where you can communicate if anything is required. Questions on the questions box, so that at the end of the session we can address your questions. And we appreciate your patience and attention during the webinar. If due to time constraints, if there is any questions which are unanswered, I will directly give you a call and discuss with you one-to-one after the session. Can somebody confirm you can see the screen and you can hear me well on the chat box, please? Okay, so we move forward. A bit of basics to start, as most of us would be knowing what is AEC, this architecture, engineering, and construction segment of the business. Drone, it has a short form, dynamically remote operating navigation equipment. It can fly autonomously and manually. UAVs, unmanned aerial vehicles. UAVs are meant to fly remotely and autonomously. UAS is a combination of UAV and a pilot controlling the flight and the system in place that connects both. Lastly is RPA, that's remotely piloted aircraft. These are the terms which would come in the drone industry and the drone technology more often, and that's why I thought to give you some basics. The agenda, what is covered in this webinar, will include a bit of introduction on the companies, DJI and Aeromotors, industrial applications of drone technology, benefits of using drones in AEC surveying and mapping, application of drones on the surveying and mapping industry, drone package with DJI M300 on the aerial photogrammetry for surveying and mapping. And also we have another LiDAR, which is also a payload which can be integrated with M300 for surveying and mapping. And Phantom4RTK, which is again, most of us would know the package. And I just want to reintroduce the Phantom4RTK for surveying and mapping. And the lastly is the DJI Terra software, aerial image processing, 3D modeling, and visualization platform that can be used along with the drone data to generate reconstruction outputs in terms of CAD, GIS formats. DJI, as many of us would know, is the world's leading drone manufacturer for enterprise and industry segment with over 15 regional offices worldwide, presence on 100+ countries and regions, and having 1,000+ channel partners. We actually are the Aeromotors Dubai. Aeromotors is basically the business partner for DJI drones for Middle East and Africa. most commonly known as drone technology enabler in Middle East and Africa, giving you a complete drone solution. A drone solution means drones, payloads, and cameras for your applications, processing and imaging software, pilot training, solutions training, after sales technical support, maintenance, and warranty support. We are known as a brand partner, reseller, stockist, and service partner for DJI with an authorized service center based in Dubai. In addition to that, we also provide certified training for drones, for pilot trainings, training on aerial softwares and analytics for asset inspections. And over and above, we also do any flight permissions if there is any specific requirement. So towards right hand side, I have just put up a simple a demonstration of how the solutions are going to be done. On a broad level, we can see there are 5 main segments of business where the industrial applications of drones are prevalent, which is public safety, construction, electricity, oil and gas, and agriculture. We are specifically on the segment focused on AEC surveying and mapping. So I would like to take you through the benefits of using drones on that. First of all, it empowers people with intelligent tools that expands their capability. It reduces risks. It digitizes your work. It captures reality, gains insights, and make decisions on real time. Reduce cost. It helps you to avoid repeat work and site visits by capturing entire site in less time with complete data. Enhances efficiency by measuring, analyzing, and delivering data with higher accuracy with automated drone flights. And over and above, one of the most important things is improved safety, which protects workers from getting into remote places and terrains by using drones to capture all features on site. The applications of drones on specific level would be in terms of surveying and mapping. On a broad segment, it would be cadastral survey and mapping, topographical survey, smart city, construction, public safety, emergency command, river management, and mining. So these applications are basically based on the payload, what we are trying to showcase during the webinar, which is capable of doing high resolution pictures, which are suitable for 3D modeling and point cloud generation. The land surveying applications basically fall into cadastral surveying, land cover and land usage, and topographical survey. You are able to do the data collection by quickly creating reality models and plots by using accurate drone solutions. You're able to scale maps using without GCPs. Also have outputs, DOM, DSM, 3D reality models, and more. So the small teams can cover large areas by operating multiple drones with a single remote control. We also have 2D orthomosaics, so we can create 2D orthomaps by the drone imagery, which can be used for visualizing the land cover and identifying the changes and doing a trend monitoring. Using this, you are able to do post-processing, keeping the digital records that can be used for land cover comparisons, so teams can monitor and changes dynamically. Very common word, topographic survey. So drones have a very good, I would say, a very high role in topographic survey. You're able to capture the drone imagery by aerial photogrammetry payloads as well as from the LiDAR, and you're able to generate DSM, DTMs, 3D models, reality models with very good high accuracy compared to the traditional and conventional methods. It is also used in urban planning. So urban planning, the subclassifications I would say is city modeling. How it does in city modeling is to create georeference data that can be fitted into BIM models. It can be compatible with GIS software. If you're using any S3 platforms, ArcGIS, so you're able to import the formats from DJ Terra into your platform so that you can use it for georeference. You can use the georeference data on the GIS platform. Urban rural classification, you're able to obtain accurate 2D maps and 3D models of landscape as frequently to do classifications with urban rural areas. The corridor mapping is a very common segment where drones are being used in terms of pipeline and as well as for roads. So this can be used for taking the geographical information, for creating 2D orthomaps and 3D models with complex terrains. And also it can be integrated with the GIS software. So in short, the drone imagery can be actually integrated into many of the software outputs, and it can be imported into point cloud, contour maps, CAD environment. So basically multiple segments you can do. Some of the few applications, I would say most common applications in AEC segment would be architecture engineering. You can use drones to map large work sites to have precise data in terms of project planning and designs. Site progress reporting and monitoring, which can be used. Drones can fly and continuously take the site progress, and you're able to do a comparison between the site progress reports on a platform. Building inspections and maintaining. This is an application which is very much prevalent in this part of the world for drones. Stockpile volumetrics. You're able to calculate volume and stock. You are able to do a redesign of the hallways. You're able to do calculations and do an estimation of the volume. Heritage site and modeling. The digitizing assets for preservation and education from cultural and natural heritage sites. Natural resource management, which is forest management and water resource. So you can use aerial photogrammetry, and also in some of the cases you can use LiDAR along with the drone to do forest management, and also use multispectral sensors to map forest, vegetation, health of the forest, and wildlife. Now, I would like to take you through the M300 initially, what are the packages are available for aerial photogrammetry, for AEC surveying mapping, and also for the other industries as a general, and then take you through the specific LiDAR formats. So a brief intro video of the M300.
Every day, good people fight fire, save lives, and keep our world revolving, even in the toughest conditions. In times like these, nothing is more critical than being able to trust your team and your tools. Meet the new Matrice 300RTK and Zenmuse H20 series. Together, they form the foundation for reinventing the world of work. The Matrice 300RTK boasts a 55-minute flight time, 15-kilometer transmission range, improved reliability, superior flight performance, and powerful intelligent functions. For the first time ever, dual vision and TOF sensors appear on all 6 sides of the aircraft, providing the Matrice 300RTK with the ultimate positioning and obstacle avoidance capabilities. Flight, navigation, and obstacle data are presented in the new primary flight display. This provides unprecedented situational awareness. A powerful flying platform requires an equally capable payload. By combining a wide-angle camera, 23 times optical zoom camera, thermal camera, and a laser rangefinder, the Zenmuse H20 series is the optimal match for the Matrice 300RTK. The new UI lets you quickly scan an area with a wide-angle or thermal camera, preview a subject of interest, and then zoom in to confirm critical details of interest after a demo flight. Then the aircraft will replicate the position, angle, and framing automatically for future missions. Save time and get highly detailed images. Every day, good people fight fire.
So that was an introduction video for M300 generally. The package for drones, which we're trying to showcase on the webinar for surveying mapping, will be primarily the DJI M300 with PSD 102S. It's an oblique camera for photographic aerial photogrammetry, which can give you data good for aerial surveying mapping. So we also have other 2 payloads from DJI, that's Zenmuse H20, which is a visual RGB camera, a hybrid camera, and H20T, which is a hybrid camera for visual RGB and thermal data capture. As we have gone through the video, so this is just a summary of what are the main features and advantages of M300 over other drones. We have 6-directional sensing and positioning, a 40-meter detection range for obstacle avoidance. We have top and bottom anti-collision beacons, top and bottom auxiliary lights, ingress protection IP45, and cameras IP44. Also, it has got a dual control mechanism where you have a master and a slave controller, when you can control the drone from different 2 points. This is the in-flight display, which is on the aviation grade. It has got all the main parameters what the pilot has to be aware on the site. RTK, the M300RTK has a built-in dual antenna. It is a dual RTK antenna, which is able to replace the compass data and able to give you a centimeter level positioning accuracy for the images. Enhanced flight performance. It's got a 55 minutes flight time on a single battery, so that makes it a very enhanced endurance. Helps it to take helps you to cover a longer area in shorter period of time, and reduce the labor and time consumption by frequent battery replacement on site. Obstacle avoidance, as you have seen through the introduction video, you have a maximum detection range of 40 meters, and it's able to identify wires with a diameter of 0.3 centimeter. It's good for inspections and to do critical infrastructure survey. It has got a built-in laser rangefinder, which helps you to measure objects up to 1,200 meters, and you can obtain the object's latitude and launch information on site in real time using the laser rangefinder. A hybrid sensor. Why do we say it's a hybrid sensor? It's got basically 4 sensors primarily. It's got a 12 megapixel wide camera, 640 by 512 thermal camera, 23 times hybrid optical zoom, laser rangefinder. That makes it unique in the industry as one of the most advanced commercial drone platform. Now, these are basically the 3 platforms which I'd like to take it through the webinar, which can be used for dedicated for AEC surveying and mapping. How different is it that we have the same drone which can be integrated with the oblique camera, which is PSD102S, and we also have the package for Phantom4, which most of us would be already aware, which is survey ready for all applications for AEC survey and mapping. The third product, the third solution I would say is M300 with LiDAR payload for customers who would like to have a LiDAR payload and have a real-time point cloud done on site. You can have a LiDAR payload. We also have that integration available. To go through on the brief of M300 with PSD, it's basically the DJI M300 and the 5 lens camera from the third party. It's an oblique aerial camera. Yeah. So that's a short video on how the PSD102S is integrated with M300 and it can take images. To give you an idea on the specs, what is the PSD1? It has got 5 lenses. Each of them have 24.3 megapixel. Total pixels will be 120 megapixel. It's a APS-C sensor. So this is ideally suitable for surveying and mapping and for 3D modeling. Advantages of using the PSD: it's efficient. It's got a 5 lens camera, and it's got a higher accuracy in terms of positional data. It's able to integrate with the DJI M300's RTK antenna. It's compatible with different models in DJI M210, M300, and M600. There's also a share data manager software which comes along with the 102S, which is able to actually process the images and to add the position data on the images and import into DJI Terra or any other aerial imaging platforms and continue with the contours processing, and to generate outputs for CAD and GIS formats. So the solution will need for you to identify your requirements for surveying and mapping. The main four components, what you would need is M300, the PSD, Share Data Manager, which comes along with the package, and then a processing software. We recommend DJI Terra. It's able to handle higher number of images compared to other platforms. And the 3D model generated from 3D DJI Terra will be highly accurate compared to other platforms. The workflow so some of you would really be interested to know how the workflow is. So we do a pre-survey before the flight. That's kind of a reconnaissance, and once a reconnaissance is done, we if we have checkpoints, maybe a couple of checkpoints to see and to actually monitor the accuracy of the final result, you can have some checkpoints. You can create routes, flight operations through the DJI Pilot app, which is already available on the M300 controller. And using that, then once you capture the site, do a mission planning and capture the site, the images can be imported into Share Data Manager to pre-process the data, and then run the final processing and error triangulation on DJI Terra, or I would say other platform similar to DJI Terra, and you can get the reconstructed 3D model. For the further outputs, you are able to generate DSM, DTMs, CAD outputs, KML files, so multiple formats based on whatever your industry requirements are. This is a 3D model what is generated by the PSD to give you an idea on that was about the aerial photogrammetry payload for surveying and mapping. I would like to take you through the LiDAR OverMap, which is another payload which is able to capture LiDAR data on site on a real-time basis. And along with the same drone, M300RTK, the advantage of this payload is that you can mount it on the drone, on a car, backpack, tether, cage, or walk. So the unit is basically usable in different type of environments based on the applications. Why do we use LiDAR? What are the main applications of using LiDAR? Many of the people would have these questions backwards. So in what applications you need LiDAR? So LiDAR is generally in GPS and denied and challenging environments, and in terms of any survey done on night, or I would say less light. So where you have no GPS signals, no communication, no maps, and no access, that's exactly an application of a LiDAR. LiDAR gives you only an RGB colorized point cloud. It doesn't take any images generally with the drones unless you have two payloads mounted on the same drone. So a brief overview of the specs. What is LiDAR OverMap is the world's best SLAM solution, SLAM simultaneously location, autonomous, and mapping. High resolution with accurate data. You're able to georeference to your survey control points and scan-to-scan registration. The direct output from the LiDAR is LAS, LAZ, DXF, and .ply, which is able to be imported into many of the environments in terms of Autodesk, Revit. So multiple environments you can then use the data. It adjusts itself from the drone speed and direction. It has got a position hold and a velocity control, a waypoint navigation. It is compatible with multiple models, including M300, M600, and M210. The core specifications are actually, it's a Velodyne VLP16 light LiDAR. It's got a capture speed of, I would say, capture density of 300,000 points per second. Range of the capture would be, I would say, 0.4 to 100 meters, dual return. It's got 360 by 360 field of view, which helps us to capture the site without any obstructions in terms of comparing to the ground-based LiDARs. You have a 500 GB storage, which will give you 12 hours of data collection. Wi-Fi enabled and 1.8 kilometer. The workflow on a LiDAR hover map would be, as I said, it can be used in different environments. You can even do a handled scanning inside the indoor environments. You can fly, walk, drive, and tether. Then download the data. There's a pre-processing software which is coming along with the payload, which actually almost 2 times the flight time. It is able to give you a high resolution outputs of the LAS, LAZ, DXF, and PLY format. So a short view of on the real-time point cloud generation, how it is generating point clouds on site. This is basically the tablet, the controller which comes along with the hover map. You will have a tablet on, so the pilot can have a look on the real-time cloud generation on site. So this will be having, it has actually the GNSS corrections. It has got a built-in GNSS capability. Addition to that, M300 has also an RTK enabled for the position of the drone. So that gives you a very high level of accuracy in terms of the data. Output formats, just to give you an idea how the output formats would look from the LiDAR compared to what you have seen on the aerial photogrammetry side. Lastly, on the Phantom4RTK, which is most commonly, popular among most of the survey and the AEC account, field is Phantom4RTK, which is able to generate the same level of accuracy. It's just the difference on endurance and the specs of the unit. It's got a flight time of 30 minutes. It can go up to 7 kilometers in FCC, centimeter level of positioning. It's able to gather data by time sync, which is the specs coming in Phantom4RTK. 20 million effective pixels, positioning accuracy of vertical of 1.5 centimeter and horizontal is 1 centimeter. It comes along with a DJI DRTK base station, which helps to give corrections to the images what is collected on site. It supports NTRIP, and also it is able to do post-processing. So specs on the imaging system, what is on the Phantom4RTK. It's a 1-inch CMOS sensor, 2.7 GSD, ground sampling at 100 meters flight altitude, which is very, very vital in terms of surveying. It's a mechanical shutter, so it eliminates the rolling shutter distortions, which can occur at high speeds, allowing high precision shots to be captured without distortion. It's coming with a built-in screen with the DJI app called GS-RTK, able to do photogrammetry and waypoint flight mission planning. You're able to adjust the overlap rates, altitude, speed, camera rates, and to also load KML files. If you have done site planning in any of the third-party apps and you want to import the KML, you're able to import into GS-RTK and launch the drone on site without having to do any planning on the site itself. DJI Terra software, I would say the industry's leading software in terms of aerial imaging and processing and for visualization, how that can be used for AEC surveying and mapping. It has got the features in terms of it's able to do 2D mapping, KML import, 2D construction in terms of field, land, urban area, able to handle multi-spectral sensors. It has got a coordinate system manager, so you are able to import the local coordinate system and data. Position POS data import, GPO reconstruction, 3D reconstruction, mission planning, and 3D modeling. It has also got an add-on function for electricity application and inspections.
After the mapping mission or oblique photography mission is completed,
users can start modeling with DJI Terra's reconstruction function. 3D models with different degrees of precision can be created. In this video, we will show you how to use DJI Terra for 3D reconstruction. Create a new oblique photography mission. Edit the mission name and then save. Click on Map to enter the reconstruction interface. Click Add Photo. Choose and add the images captured by the DJI aircraft. After the images have been added, DJI Terra's map will show the position of each picture. Click on the right arrow to open the picture list. Double-click on the picture name to preview the picture. Click Manage to choose and delete photos. Choose a resolution. Note that increasing the resolution will increase reconstruction time. If choosing none in other model formats, only 2 models start reconstruction. In addition, users can rotate the model, press and hold the scroll wheel, then drag the scroll wheel accordingly, or hold the control key, then hold the right click of the mouse, and drag. After clicking on Annotation and Measurements, users can measure the reconstructed model's coordinates, distance, area, and volume. Select the coordinate icon and click any position on the model to measure the position's GPS coordinates and altitude. Click on the distance icon and click any 2 positions on the model to measure their spatial distance. Click on the area icon and choose any points in the model to form a surface or a polyhedron to measure the surface's area or the polyhedron's vertically projected area. Click on the volume icon and choose any points in the model to form a base plane to measure the cut volume and fill volume between the plane and the model. If the Show Camera Pose option is enabled, the shooting position and shooting angle of every picture will be displayed. Click any position on the model to check the original HD pictures that have been captured in that position. In addition, users can export the quality report to learn the model's reconstruction quality. The reconstructed 3D model can be imported to a waypoint mission.
Yeah, that's about DJ Terra. I can actually send you those things directly on one-to-one. So to give you a workflow, what are the things you need in terms of a surveying drone package? You need to have a drone with a third-party app to take the images from site, do the modeling on a cloud, or either that's a cloud environment. You can export the model into object or LAS format, and you can do measurements automatically and then modeling in 3D. So these are the basic workflow what you can use for surveying and mapping. As you've seen, DJ Terra is it's actually a very powerful software able to handle many thousands of images, and it's able to do a faster reconstruction and processing compared to other platforms. You can also use DJ Terra to do a vegetation measurement in terms of power line, in terms of forest, and create a single 3D model of the transmission tower. That's it for the webinar. What we intended to cover during